Today we discuss polynomials in 10th class. Introduction. If polynomial is a function which is in the form of a0 plus a1x plus a2x square up to so on an x power n. This is the general form of the polynomial. And here highest power of the polynomial is called the degree of the polynomial. If the highest power is 1, then the polynomial is called the linear polynomial. And if the highest power of quadratic polynomial is 2, then the polynomial is called quadratic polynomial. If highest power of polynomial is 3, then the polynomial is called cubic polynomial. If p of x is a polynomial and k is any real number, then the value of the polynomial is defined as, if we replace x in the p of x, then we get the value of the polynomial. Suppose here x square minus 3x minus 4 is the polynomial. Now we have to find the value of the polynomial at x equals to minus 1. Now we have to substitute minus 1 in the place of x. We will get minus 1 square minus 3 into minus 1 minus 4 which is equals to 0. If the value of the polynomial is 0, then that the value of the polynomial is 0, then x is said to be the 0 of the polynomial. In general, if k is the 0 of the polynomial, ax plus b, then p of k equals to ak plus b, because we substitute k in the place of x, therefore ak plus b. Now we equate ak plus b equals to 0, then k equals to minus b by a, where minus b by a is the 0 of the polynomial ax plus b. So the 0 of the polynomial ax plus b is minus b by a. That means here b is the constant term, therefore minus into constant term divided the a is the coefficient of the x, therefore 0 of the linear polynomial ax plus b is minus b by a, which is defined by minus of constant term divided by the coefficient of the x. So what is the geometrical? What is the geometrical meaning of the zeros of the polynomial? We know that a real number is the 0 of the polynomial, then the value of the polynomial is 0 at that point. So, if but why are the zeros of the polynomial is important? To answer this, first we will see the geometrical representation of linear, quadratic and cubic polynomials and the relationship between zeros. What is the geometrical meaning of the zeros means? If a number is a 0 of the polynomial, then the value of the polynomial at that number must be equals to 0. Therefore, for example, this is the graph of linear polynomial y equals to 2x plus 3. This graph of the linear polynomial is a straight line and this passing through the points minus 2 comma minus 1, minus 3 by 2 comma 0, 0 comma 3 and 2 comma 7. Thus the 0 of the polynomial 2x plus 3 is the line which intersects at the x-axis. The line which intersects at the x-axis is this point. The line intersects the x-axis at the point minus 3 by 2 comma 0. Therefore, minus 3 by 2 is the 0 of the polynomial. By using graphical representation, we can easily find out the zeros. The line of the graph which cuts the x-axis is the point is called the 0 of the polynomial. Next one. Now in general, linear polynomial ax plus b, linear polynomial in the form of ax plus b, and here a is not equal to 0. Here y equals to ax plus b intersect the x-axis at point minus b by a comma 0. Therefore, here minus b by a is the 0 of the polynomial. because the curve which intersects at the point in the x-axis, that point is called the zero of the polynomial. Now, geometrical meaning of the quadratic polynomial. Here, this is the quadratic polynomial graph, and this quadratic polynomial intersects the x-axis at 2 points. That is minus 1 comma 4. Therefore, minus 1 comma 4 are the zeros of the polynomial. Now, here case 1. The graph of x-axis it cuts two distinct points. In the x-coordinates of A and A dash. This is A and this is A dash. And this is A dash and this is A. And the two zeros of the quadratic polynomial are here A and A dash. A dash and A. Now, here the graph of the x-axis cuts at exactly 1 point. So, here there is only one common point. Here A and A. Here the quadratic polynomial has repeated zeros. That is A comma A. The polynomial has only one zero. Next, here the graph of the quadratic polynomial neither cuts the x-axis. Therefore, the polynomial has no zeros. The polynomial has no real zeros. Because this is real axis, the graph of the polynomial does not cut the x-axis at any point. So, this graph has no zeros. Next, we will move to examples. Look at the graph given below. Each of the graph p of x, where p of x is a polynomial. For each of the graph, the number of zeros of p of x are. Here, the graph cuts x-axis at only 1 point. Therefore, the number of zeros is 1. Here, the graph cuts at 2 points. Therefore, number of zeros are 2. Here, the graph cuts x-axis at 3 distinct points. Therefore, the number of zeros are 3. Here, the graph cuts x-axis at only 1 point. Therefore, the number of zeros are 1. Here, the graph cuts at x-axis at only exactly 1 point. Therefore, the number of zeros are 1. Here, the graph cuts x-axis at 1, 2, 3, 4. 4 points. Therefore, the number of zeros of this polynomial p of x is 4. Now we will move to exercise 2.1. For this polynomial, the graph does not cut x-axis. Therefore, this polynomial has no zeros. This polynomial cuts x-axis at only 1 point. Therefore, the number of zeros is 1. For this graph, cuts x-axis at 3 points. Therefore, the polynomial has 3 zeros. Here, the graph cuts x-axis at 2 points. Therefore, the polynomial has 2 zeros. Here, the graph cuts x-axis at 4 points. 1, 2, 3, 4. Therefore, 4 zeros. Here, the graph cuts x-axis at 1, 2, 3 points. Therefore, this has 3 zeros. Now, we have to find the relationship between zeros and coefficient of the polynomial. We have already seen that ax plus b is a linear polynomial. Then the zero of the polynomial is minus b by a. For quadratic polynomial is in the form of ax square plus bx plus c. Ax square plus bx plus c, where a is not equal to 0. Now, then you know that x minus p and x minus q are the factors of the polynomial. Then ax square plus bx plus c equals to k into x minus p into x minus q, where k is a constant, and this can be written as k into x square minus p plus q into x plus c cube. Now, comparing the coefficient of x square on both sides, we will get a equals to k, b equals to minus k into p plus q, and c equals to k into p into q, where this gives the sum of the roots. P plus q equals to minus b by a, and also product of the roots. Pq equals to c by a, where b is the coefficient of x and a is the coefficient of x square and c is the constant term. Now sum of 0 c plus b equals to minus b by a. Where minus b is the coefficient of x and a is the coefficient of x square. Where b to c by a. Where c is constant and a is coefficient of x square. Find the zeros of the quadratic polynomial x square plus 7x plus 10. X square plus 7x plus 10 and verify the relationship between zeros of the and the coefficient. Here, the factors for 10 are 2 into 5. Therefore, 7x can be split into 5x plus 2x. Now, we take x common from these two terms, we will get x into x plus 5. And plus 2 from these two terms, we will get x into x plus 5. And x plus 5 from these two terms, we will get x plus 5 into x plus 2. Therefore, the zeros are x equals to minus 5 and x equals to minus 2. Here, we will get two zeros, x equals to minus 5 and x equals to minus 2. Now, we have to find the relationship between these two zeros. That means, let alpha equals to minus 2, beta equals to minus 5. Then alpha plus beta. That means sum of the roots, which is equals to minus 2 plus minus 5, which is equals to minus 7. Minus 7 can be written as minus of plus 7 by 1. Here, where 7 is the coefficient of x. That means minus of coefficient of x. Here, 1 is the coefficient of x square. Now, product of the zeros, that is alpha into beta. Alpha into beta is minus 2 into minus 5. That means 10. 10 can be written as 10 by 1. Where 10 is constant term and 1 is coefficient of x square. Where 10 is constant term and 1 is coefficient of x square. Next problem. Find the zeros of the polynomial x square minus 3 and verify the relationship between the zeros and coefficients. Therefore, x square minus 3 can be written as x plus 3, x plus root 3 into x minus root 3. Because this is in the form of a square minus b square minus b square is a plus b into a minus b. That means x plus root 3 into x minus root 3. Therefore, one of the zero is 1 0 is plus root 3 and another 0 is minus root 3. Now we have to verify the relationship. That is alpha equals to root 3, beta equals to minus root 3. Therefore, alpha plus beta equals to root 3 plus of minus root 3, which is equals to 0. Which is equals to 0 by 1. Which is equals to minus of coefficient of x divided by coefficient of x square. Coefficient of x divided by coefficient of x square. Now alpha into beta. That means root 3 into minus root 3, which is equal to minus 3, which is equal to constant by coefficient of x square. Constant by coefficient of x square. Find the quadratic polynomial. The sum and the product of whose roots are minus 3 and 2 respectively. Here given that sum of the roots, that means alpha plus beta equals to minus 3 and product of the roots, that means alpha into beta equals to 2. Now quadratic polynomial is x square minus x into alpha plus beta plus alpha beta. Now x square minus x into alpha plus beta value is minus 3 plus alpha beta value is 2. That means x square plus 3x plus 2 is the required quadratic polynomial of sum of roots is minus 3 and product of the roots is 2. Let us consider 2x cube minus 5x square minus 14x plus 8. Now, the polynomial is 0 at the value 4, minus 2, 1 by 2. Therefore, the sum of these zeros is 4 plus of minus 2 plus 1 by 2 is 5 by 2. Here 5 by 2 can be written as minus of minus 5 by 2. Here minus 5 is the coefficient of x square and 2 is the coefficient of x square for x cube. Therefore, sum of the zeros of the cubic polynomial is minus of coefficient of x square divided by coefficient of x cube, and also product of the zeros. 4 into minus 2 into 1 by 2 is equals to minus 4. Minus 4 can be written as minus of minus 8 by 2. Minus 8 by 2. Therefore, minus into constant term divided by coefficient of x cube. In general, it can be proved that if p, q, are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then sum of the roots is minus b by a, and pq plus qr plus pr is c by a, and product of the roots is minus d by a. Verify that 3, minus 1, 1 by 3 are the zeros of the cubic polynomial p of x. Therefore, first we have to check for p of 3. 3 into 3 cube minus 5 into 3 square minus 11 into 3 minus 3. Here 3 cube value is 27, 27 into 3 is 81. 3 square value is 9, 9 5 is 45, 11 3 is 33 minus 8. Therefore, minus 45 minus 33 minus 3 is minus 81. It is equal to 0. P of 3 value is 0. Similarly, P of minus 1. P of minus 1 is equals to 3 into minus 1 cube minus 5 into minus 1 square minus 11 into minus 1 minus 3. Here minus 1 cube is minus 1, minus 1 into 3 minus 3, minus 1 square is plus 1, 1 into minus 5 is minus 5, minus into minus plus 11 minus 3. Minus 3 minus 5 minus 8, minus 8 minus 3 minus 11, minus 11 plus 11 is 0. 3 into minus 1 by 3 whole square, minus 5 into minus 1 by 3 whole square, minus 11 into minus 1 by 3 minus 3. This is minus 1 by 9 minus 5 by 9 plus 11 by 3 minus 3. Now, LCM for 9, 9, 3 is 9. And minus 1, minus 5, 3 3s are 9, 3 into 11 is 33, 9 into 3 is 27, therefore 0 by 9 which is equals to 0. Hence, the value of the polynomial at 3 and minus 1 and minus 1 by 3 are zeros. Therefore, 3, minus 1, 1 by 3 are the zeros of the polynomial 3x cube minus 5x square minus 11x minus 3. Now, we have to find the relationship between these zeros. Sum of zeros. That means let alpha equals to 3, beta equals to minus 1 and gamma equals to minus 1 by 3. Sum of the zeros, that is alpha plus beta plus gamma, equals to 3 minus 1 plus of minus 1 by 3, which is equals to 3 minus 1 is 2, 2 minus 1 by 3. That is 3 2 is 6, minus 1 5 by 3. 5 can be written as minus of minus 5 by 3, which is equals to minus b by a, where b is the coefficient of the x square and a is the coefficient of x cube. Next, three into minus 1 plus minus 1 into minus 1 by 3 plus 3 into minus 1 by 3, which is equals to minus 3 plus 1 by 3, 3 cancel, minus 1, minus 4 plus 1 by 3. 3 into minus 4 minus 12, minus 12 plus 1 minus 11 by 3, which is equal to c by a. Here minus 11 is coefficient of x and a is coefficient of x cube. Next, alpha, beta, gamma. 3 into minus 1 into minus 1 by 3. 3 gets cancelled, which is equals to 1. Here 1 is written as minus of minus 3 by 3, which is equals to minus d by a, where d is the constant term and a is the coefficient of x is cube.